Hello everyone, let us start with our question. In this question, what is given that 6 point charges are kept on the vertices of a regular hexagon of side L and center is given as to be O. So these are the charges which have been placed on the these sides of a hexagon. Now K is a value is given as to be, we can assume this value as to be 1 by 4 pi epsilon Q by L square. So this factor we could assume that it is K. Now which of the following statement is are correct? So basically we need to find whether electric field at O is given as to be 6K along OD. We need to find this value. So we can check this one, whether electric field is like this or not. Okay, now for this part, for example, this charge is Q. From here to here, what would be the value of the force? We know that force value would be equals to 1 by 4 pi epsilon, then Q divided by L square, because distance would be L. So it is a regular hexagon. So for positive charge, it is away from. Basically, it is away from. So this would be the direction for this positive charge. We can just write its value to be K. This is a negative charge, so it would be towards the negative charge. Everything is same, so we can say that it would be Q. Now here, if we see this, so it is a negative charge, so it would be towards the negative charge. It is K. Now here it is positive charge, it would be away from positive charge. It is what? It is equals to K. Okay. Now here is twice of Q. So it is twice Q. That means here the force would be 2 times of K. And here is plus 2Q. So it would be away from the positive charge and the magnitude would be 2K. Okay. Now we see that this 2K and this 2K, these are in the same direction. So we can just write their value as equals to what? Their value would be equals to 4K. Now we just need to find what is the net resultant of these 1, 2, 3, 4 quantities. Okay. Now in this direction, what would be the value in this direction? If you draw this direction would be what? This direction is K plus K, that would be 2K. And what is this direction? It would be what? K plus K, that means 2K. So this is 2K, this is 2K. And what is the angle? Angle is 120 degrees. Okay. Now what would be the net value? If we call the net force value would be equals to what? Net value would be equals to, if there are two vectors, how to find the value of net? We just square these terms. So it would be 2K square plus 2K square plus 2 times 2K into cos of the angle. So A square plus B square plus 2AB cos of theta. So we just square this. So it would be 4K square plus B square this. It would be 4K square plus then 2 into this value into this value. So that means 4 into K square. And what is the value of cos 120? It is minus 1 by 2. It is minus 1 by 2. Okay. Now this and this would be gone. And it would be minus 4K square. So 1 power would be gone. So F net value would turn out to be what? F net value would turn out to be 2K. Now this is 2K due to what? Only due to this one, this one, this one, and this one. And there was already 2K here and 2K here. That means our net, we can say that net force, F net at O would be equals to this value 2K. And due to the positive and the negative charge as 2K plus 2K. So this value would turn out to be 6K. And what is the direction? We can see that direction would be along from O to D. So that means A statement is correct. Let's check our B statement. Potential at O is 0. At O, the potential value is 0. So that would be 0. Why? Because we see how do we write potential? We write potential as, we just write potential here as V equals to 1 by 4 pi epsilon. And now this distance for each and every one from here, it is always L. So we can just take L to be outside. And then we just write what is the total charge. What is the total charge? We can just write Q, because this factor would be same for everyone. So we can just write here as summation of Q. Now what is the net charge? If we could see, so this is plus Q minus Q, so this would be gone. Plus Q minus Q, this is gone. Plus 2Q minus 2Q, this is also gone. So net charge is what? 0. So we say that potential would be 0 at O. So this is the potential 0 at O. So we have seen that our B statement is also true. Now potential on all point on the line PR is same. So this is the line PR. So the potential would be same. This is also true. Why? The reason being, so this and this, these are forming what? If you could rub this part, if you can just rub this one. Okay. Now what are this and this part forming? These are forming a dipole. So these are forming a dipole. These are forming a dipole. Similarly, this and this would be forming a dipole. Here and here, there would be a dipole. And there, here and here, these are also forming a dipole. Okay, charges are same, plus minus, here plus minus, and here plus minus. So basically there are 3 dipoles. Okay, Now we know that if we calculate potential on the midpoint, for example, this would be lying on the perpendicular bisector. If we calculate the potential on the midpoint, on so its value would be zero. Its value would be zero just at the midpoint. Okay. So along this line, potential value would be same for each and every point. So if you move from P to R, whether we move from P to R in this direction, so potential value would be constant. Okay. So we can just prove. Now for here part, let's assume for this part, okay, we just wanted to calculate potential here. So we see that this is positive, this is negative, and the distance are same. So by the same logic, the total charge would be what? Total charge would be zero. So that means potential here would be zero. Similarly, we can check potential here. Similarly, we can check potential here. So that means C option is also true. Now we need to check whether potential on all points on the line ST is same. On the line ST, no, there would not be same. For example, if we consider a point here, let us consider a point here. So here distance is something else, here distance is something else, from here distance is something else, from here distance is something else. So we see that these dipoles, these are not cancelling potential at these locations. That means this option is incorrect. So what are our correct option? A option is the correct option, B option is the correct option, and C option is the correct option. So hope you have understood this solution. Thank you. Hello everyone, let us start with our question. In this question, what is given? For spherical symmetric charge distribution, variation of electric potential with distance from center is given as to be V equals to Q divided by 4 pi epsilon naught R naught for R less than R naught, and V equals Q divided by 4 pi epsilon R for R greater than equal to R naught. And this is the variation which has been shown. So for R equals to R naught, potential value is constant, and after R greater than R naught, it is decreasing with a, so it is inversely proportional to R. So it is decreasing like this. Okay. Now this could be a distribution for, it can be a distribution, can be a distribution it can be distribution for what? It can be distribution either for a shell or conducting sphere. Okay, conducting sphere. By the diagram we can see, because inside there is no potential, so the potential is zero. That means electric field, sorry, potential is constant, therefore electric field would be zero. So that means there is no charge inside this location. Okay, inside at R less than R naught. Okay, so it would be a case of either the shell or conducting sphere. Now we need to find which of the option is the correct. Now total charge within 2R R naught is given as R naught. So in the first part, in the first statement, it is given as for R equals to twice of radius. Okay, twice of radius R naught. The charge is Q. So is this right or wrong? So this statement is true. Why? Because if, for example, if this is our spherical shell, okay, if this is our spherical shell of radius R naught, the radius is R naught. Now if we are outside this shell, okay, at a distance of 2 R naught, so here it is given as to be, radial distance is given as to be 2 R naught. Okay, so whole charge would be inside this shell. So we can say that first statement is a true statement. That means it is correct. Now total electrostatic energy for R less than R naught is non-zero. Okay, that means inside this, for R less than 2 R naught, sorry, inside this 2 R naught, it is not equal to zero. So in the second part, we know that electrostatic energy, basically we can say that potential energy would be equals to Q into dV, or the change in potential. Okay, multiplied by the change in potential. Let's say from the surface, we are moving from the surface up to a point at a radial distance R naught. So we can say that it would be Q. Then V at the surface, we just write the value. Final value would be at 2 R naught minus initial value. We say that initial value at R naught. Now this value, if we see from the graph itself, now at 2 R naught would be something here. It is the location 2 R naught. So the value of the potential at 2 R naught and the value of the potential at R naught, whether they are same or unsame. So they are not same. So that means this term would not be equal to zero. If this is not equal to zero, then potential would not be equal to zero. Electrostatic potential energy. That means second option is also true. Now at R equals to R naught, electric field is discontinuous. Okay. Now at R equals to R naught, in the C part, in the third case. Now here, just before R naught, to the left of R naught, okay, to the left of R naught, we can see electric field. We know electric field is given as, electric field is equals to minus dV by dr. Now in this diagram, just at R less than R naught, okay, what is V? V is constant. V is equals to constant. Okay, V is constant. Now V is constant. So we can say that our E would be what? Differentiation of a constant thing. That would be 0. That means electric field would be 0. Now if we take R greater than R naught, if we take R greater than R naught, that means for this portion just to the right of this R, sorry, just to the right of R, we are taking the distance R naught. That means the this R naught is the capital radius. That means radius. So here we see that potential variation is 1 by R. So we can say that it would be some constant time divided by R. Now if we take E value, so it would be minus C divided by R square. Now this value is not 0 because R would not be infinity, because it would be 0 when R is infinity. That means there is a discontinuity from 0 value to a certain value. That means this is a correct statement. It is a discontinuous. Electric field is discontinuous. Now there will be no charge except R less than R naught. Okay, so it is given that there will be no charge. So we can just see in this case. Now if there is a if this is a conducting sphere, where will be the charge? Charge will be at the distance of what? R equals to R naught. So that means here the statement which is given that there will be no charge except at R less than R naught. That means inside this is wrong. Why? Because if this is a spherical cavity, then the charge would be residing exactly at R equals to R naught. So this statement is wrong. So what are the correct statement? 1, 2 and 3. So what would be the correct option? A is the correct option. Hope you understood the solution. Thank you.
Hello everyone. Electric potential at a point xy, z in space is given. Here it is V is equals to 4x square volt. Electric field at a point 1, 0, 2 is. So if we talk about the electric field at a point, it is equals to differential of potential with respect to x, partial differential, I cap, the same for y and the same for z. So if you see the function is only in x, so the partial differential with respect to y and with respect to z, it will be 0. So it will be only in I cap direction, right? So you can differentiate it. The v is given, it is 4x square. So if you differentiate it both sides, I will write down del v by del x is equals to 8x. Now x is given here, it is 1. Right? If you see, it is 1, 0, 2. So x is 1. So I will write down the Ex is equals to, if you write down this quantity as Ex, so this Ex is equals to 8. Right? Now I will write down the electric field at any point 1, 0, 2, it is minus 8 I cap volt per meter. And if you see here, we can write down it is. Thank you.